Hello, class. I hope everybody's staying safe and warm here on this icy Thursday morning. But I did want to post up a video here for you. I've been messing around with Automation Studio here a little bit, and I thought I would help you if you want to use that to complete the midterm lab, which is just basically a paper lab. Now, again, I told you in class that you can do that on paper, just draw it out, and if you so desire, you can use Automation Studio to complete it, and I'm going to show you how to do that. It does make a neater end product, and this is something, if you learn how to use this, something that might help you in some other classes or even on your job, because it is a pretty good program. It just takes a little bit of time to learn it, and we really haven't had time in class to do that. So if you've got it downloaded, and that's why I'm not making it a requirement, because I know some of you are having problems downloading this on your personal computers and tablets or whatever. So that's why I'm not making it a requirement to do this for the midterm lab. But again, if you want to do that, please do so. It's will make a nice, neat project. Okay, so if you haven't done so already, you can download Automation Studio there from your modules, and it's the very top module, Automation Studio Remote Access E7. And here's your installation instructions. And if we open that up, then you see here, and depending on your machine, you probably want to download the 64-bit, and you're supposed to read these instructions here. So first, and it walks you through how to do that. I'm not going to take a lot of time to do that now, but just make sure that you don't click on the licensing tab, and you'll see when I bring the program up, you'll see what I'm talking about there if you haven't already done it. But that's how you get the program. So if you've got it working and running on your machine, then you can do it. Now, you can also do this in the classroom if you want to. You can come in, there'll be time in the classroom if you want to sit and work on the projects in the classroom with this. So you don't necessarily have to do it at home as well. Okay, so I'm going to bring up Automation Studio, and depending on your computer setup, you'll have to find it. Quickest way is to click your start menu there and just click on Automation Studio, and it pops up here. And I think the default program that it loads, the default project, is okay to use. It seemed to work okay for me. Some of these, if you try to put components in, it'll say it's not compatible for this type of project. And I'll explain a little more about that in a minute. So here we are with our Automation Studio project loaded, and it's blank. And you should have you have a list of generic components down here on the left-hand side, and whichever one you have selected, I'll show you what's in that folder here below that. So we're not going to be working with hydraulics today, just electrical. And the two categories that we're going to be working with is electrical control, the JIC standard. Don't click on the IEC, that's international. We're not going to use them. We're going to use the JIC standard, and we're also going to use ladder for Allen Bradley PLC. Now, that's what we're going to do. Now let's look at the project that we're going to go through here. And this is an example of the midterm lab. So we're going to create a PLC program that will do the following. When push button 1 is pressed, light number 1 will turn on. When push button 2 is pressed, light number 2 will turn on. When push button 3 is pressed, light number 1 and 2 will turn on. And when push button 4 is not pressed, light number 4 will turn on. Okay, so that's our parameters for the program. So we're going to need 4 push buttons and 4 lights. I just see that should have been light number 3, but we're going to call it light number 4 anyway, so I don't have to change my video. Okay, so here we go. So we need the JIC electrical components here, and the first thing we're going to do is put some power sources on here, and we're going to work with 24 volts. So we have 24 volts here, and we need a couple of those. So you can either just drag 2 of them up, or you can copy and paste. I'm just going to go ahead and drag 2 of them up. We could tie it all to one, but it just makes it a little neater and easier. I'm going to leave those up there for right now. And then we need a 0 volt common, so I'm going to put that up here. We could use ground too. Ground will work as well. And we're going to need a couple of those, so I'm going to drag a couple of those there. So we have our power sources on here. We're going to go to the output components here, and we're going to get our signaling devices, because we're going to use lights. And you notice down here we have pilot light, pilot indicator lights. So I'm going to put that over here, because we're going to have our, and that's going to be light number 1. And actually I'm just going to call it LT1, just like that, because it makes it look neater. And I click that, and now it says light 1 above it. Now I can just go ahead and go Control C, Control V, and copy another one, and hopefully that's gonna, I can double click on that. No, that's the problem, it doesn't let you change the alias. Okay, so I'm going to grab another one here, and we're going to make that light number 2, LT2. And then we need LT4. Okay, light 3 got broke, I guess, or something. Or the engineer screwed up when he designed the machine. Okay, so we got our 3 lights there. And now we're going to go ahead and put in our input cards. And you can do this, well, there's a certain order you need to do a couple of these things, and I'll explain that in a minute. But we're going to click down here on the PLC cards, and we need an input card. We're going to put that right there. And we're going to need an output card, and we're going to put that clear over here. And we can go ahead and connect. Well, I'd like to get that lined up there. There we go. And we can connect. So to connect wires, if you run your mouse to the end of the component, and you see that bullseye come up, that target come up, and then you can go over here, and then when it appears again, that means you're on the next connection point. So we're going to put light 1 on output 0. We're going to put light 2 on output 1. And we're going to put light 3 on, or light 4, I'm sorry, on output 2. So there we go. And the problem is it's the, let's see if I pull that down. Now I'm going to pull that down a little bit so you can see the tags on the lights. Might help some confusion. And let's go ahead and drag that over so the lines aren't overlapping. And you can move those lines around like that. Okay, I just click on that, and then I use my arrow over. Okay, so now we can see all the tags on the lights. Okay, so now we're gonna go ahead and add our inputs. And what I'm going to do with that first off is I'm going to add my push buttons, and we're going to make those like real world type push buttons. Now on the video I watched, they could change the colors of these buttons, but I wasn't able to do that in here. And if some of you figure out how to do that, let me know, and we'll see. But okay, so I'm just going to drag this push button over here, and it's going to be, I'm going to call it PB1, and then hit the check mark, and I'm going to make it smaller too. Okay, I'm going to make it smaller. So there's PB1. I'm going to get PB2. There we go. Here's my push button 2. And PB3. Make that smaller. Come on. There we go. That's smaller. And push button 4 coming up. PB4. Okay. So that's a little big, isn't it? I could have left them the normal size. So now we have our 4 push buttons and our 3 lights. And now I'm going to add the contacts here. So these buttons can be interfaced to the input card. So I go back over here to my contact link, and I click on that, and if you look down through here, I have normally open push buttons. So I'm going to put those in there, and that menu pops up, and it comes up with a menu over here. A list on the right side says compatible simulation variables, and if you scroll down that list, you see we have PB1, PB2, PB3, and PB4. Well, I'm going to link that to PB1, so I just put my mouse there and right click and do create link. Bang, and it comes up and it says PB1 there. So I'm going to go ahead and hook that to input 0. And then I can close that box, and then I'm going to grab me another normally open switch, and I'm going to move it down so my tag doesn't overlap. And then I'm going to select from my list over here PB2 and right click on it and create link. And so that link's created. I'm going to go ahead and hook him up to input number 1. Move my line over there a little bit to make it. Oh, shoot. And if you get, see, I got an extra line in there. I'm just going to delete that. You can just highlight it and delete it if you screw up. There we go. We'll just leave that like that for now. So there's PB2. Now I need push button number 3. We're going to put that right here. And we're going to link that to our human interface button there. Create link. And then we need push button number 4. I'm going to pull him up here. Oh, I forgot to hook up 3, didn't I? And we'll get them both here at once. Push button number 4. And right click, and I created my link. Okay, 3 goes to input 2, and I'm going to see how that line come up there. I'm going to move that. And if you highlight it and then use your arrow keys, you can position it where you want. And then PB4 goes to input number 3. I'm going to highlight that line. It's not actually connected to those other inputs, but it looks like it is. Okay, so now we have to put voltage to those switches, so I'm going to go here and hook this up. Hopefully will it let me. This could get a little messy here. Let's move that over. Let me try this. I'm going to hook this one up first, all the way up. Now, I think you can put nodes on there. And I got to go up there. So you have to go up. You might find an easier way. I'll hook that one there, and then I can move that arrow over. There we go. Now that one didn't hook. I'm going to hook that one up there. There we go. Okay, that looks a little squirrely, but at least they're all hooked up. Okay, so that's our inputs and outputs. Oh, we got to hook up our commons here, our ground. And again, I'm going to move that wire down out of the way so you can see more clearly. Then our outputs, we're going to hook those up here again, like we did. I'm going to try to be a little neater with this. There we go, and then we'll hook up the output common. Now this, there we go. Move that over here, so there we go. Okay, so we've got all of our hardware connected, and if we look, let me see if I go to simulation here if it works without a program in here. So if I push 1, you see input 1 comes on, input 0 comes on, input 1 comes on, input 2 comes on, and input 3 comes on. So that's working. So I'm going to stop the simulation. So now we have to do our program. Now, and I tried to do the Studio 5000 programming, and it keeps telling me that this isn't the right project for that. So instead of fussing around with that, because the lab doesn't ask you to put it necessarily in Allen Bradley 5000 PLC format. So we can just use ladder for ABPLC. So that's more of like a generic program. And so now we're going to put in our rung. So I click on rung and I put that up here, and it's going to be too big, but you can resize it. So I'm going to put it in the rung. Okay, so there's the rung. And now we need to start adding our logic. So you notice here we have contacts. And we are going to click on that, and we have examined if closed, examined if open, and that's the main two that we're going to need. So we're going to pick an examined if closed contact and put up here in our first rung, because our first logic is when push button 1 is pressed, light number 1 will turn on. So it comes up with a question mark on there. So if I double click, if I double click on the component, then it comes up here, and again I have the list over here, and we're going to connect that to input 0. So I'm going to create the link, and it tells us that that is connected to input 0. And so all we need now is an output on here. And so we go to coils, and we have output energized. And I just put that in line. And we're going to call that light 1, LT1. And then we're going to double click on it again, and we're going to hook that over here to output 0 from our variable list. And so we're going to create a link and close it. And now we see that that's connected to output 0. I'll connect my lines. And there we go. Now we could go ahead and test that if we want to. Go to simulation mode. And I'm going to push button 1. And there, see my light comes on over there. So guess what? It works. It works. Okay. So now we're going to do our next one. If button 2 is pressed, light 2 will come on. So we just got to go back through the same process again. Go to contacts. We want to examine if closed. We're going to try to put that right in line with the other one. And then we need an output energized. Okay, and that's light 2. And but we need to put that to output 1. And we're going to create the link, close it. There we go, we're output 1. And this one needs to be connected to input 1. Go to our list, input 1, right click, create link. Connect our lines. Go back to turn the simulation back on. Try our button. And it works. We're not going to we didn't screw up output 0 by doing that. So you always want to double check yourself, especially if you're doing a big program. You don't want to get too far down into it and then find out you screwed something back up at the beginning. Okay, so now we're going to go to our next logic statement, which is when push button 3 is pressed, lights 1 and 2 will come on. Okay, so how could we do that? Well, we can go ahead, we could just add the contact down here and in a branch, really. There might be a couple ways you could do this statement, but we're going to go ahead and just get our examined if closed contact. And we're going to put a branch here, and this is going to be a little bit squirrely because it's overlapping with our tags, but I'm going to go ahead and put that up there. You know what I'm going to do? I'm going to go ahead and cut this. Control X. I'm going to skip a couple lines here so we have the space. I should have done that. And we're going to paste that back. Now that's better. Okay. We're going to go ahead and hook that back up. Now, I'm going to move this down a little bit. Now we're good. So that needs to be connected to input number 3 or number 2, correct? And we're going to create a link. Okay, so we have that branch there. And then we're going to, I can just copy and paste that, move it down here, and connect it. Why is that doing that? I don't want that there. I want that there. There we go. So now we have a branch there that should turn on both lights when input 3 button is pressed. So let's test it. I'm going to simulation, push button 3. And both lights come on, but for some reason it's just showing one on in my simulation. Interesting, but the logic is right. It must be a bug in the simulation because both are showing on in the program. If you look at the program rungs, you see that they highlight green and they're showing that they're on. But on my output card, it's not showing on, so I'm not sure what that is about. Okay, but we know the logic's right. Okay, so that's our third statement, and then our fourth statement is when button 4 is not pressed, light 4 will be on. So we have push button 4 here, and we're going to create a contact for that one. Examine if closed. Nope. We want examine if open, because it said when it's not pressed. I'm going to double click that, and we're going to hook that to input 3, create link. And we're going to do our output energized coil. And that's light 4. Move it down a little bit. Oh, I need to connect it to output 3. Create link. Connect it together. And we've got it. So now if I turn on my simulator, output 3 is on, and if I press button 4, it goes out. Okay, so let's run back through the whole thing again. Push button 1 pressed, put 2 comes on, push button 2 is pressed, comes on, push button 3 is pressed, and for some reason, maybe I don't have that addressed to the right. Well, it has to be. Both, something with the program doesn't allow it to work, but the logic is correct. And now, so that's how you create a PLC program with Automation Studio. Now, again, you don't have to do this. You can draw it out on paper, but just make sure all your inputs and outputs are right. But if you want to use this, it does make kind of a handy setup. And once you get one set up with the inputs and outputs, then you can you don't have to delete the whole thing. You can just delete connections and reconfigure everything. So it's kind of fun to play with, and I'll show you a couple things I did, and also I'm going to post up a link of another video that shows you how to do this program that I'm going to show you here. I'm going to save this project so I don't lose it. There it is. PLC, make sure you save your projects if you do them here. PLC midterm lab example. Okay, so there we go. That's saved. Maybe. Save. I think it's probably just... I hope we're not crashing here. Come on, baby. There we go. Okay, so here's a project I created and added a timer to it. So if we go to simulation here and look at that, if I push the start button, my motor runs. I put this little flashing indicator light up here to show that my three-phase motor is running, and then it'll run for 10 seconds and then shut off. So if you want, this is kind of a fun way to mess around and learn the logic and also how the circuits are connected as well. So it's kind of fun to play with. So that's it. If you got any questions about this or having any problems, just send me best way to do is send me a text message, and then I'll try to get to the computer, because right now I'm at home and probably will be so all day. I don't know. I still hear the ice hitting the window out there, so have fun and stay safe, and I'll see you guys on Tuesday, hopefully.